Alright guys, so in this video what I'm gonna do is show you how to find something called the line of best fit or regression model for the advertising and sales table that we were discussing in the last video. So currently I'm on the screen where we entered the data into L1 and L2. On the last video we saw a scatter diagram that is associated with it. What I'd like to do now, though, is show you how to come up with a linear equation that best represents this data. And basically what we mean by that is the equation can be used to generate some of the values in the table to a certain extent, but also be used to predict values that we are not seeing in the table. So what we do is we're going to press the Stat key, and we're going to arrow over to the Calc column, and we're going to select option 4. So you can scroll down to 4 or press the 4 key, whichever you prefer. I'm going to go ahead and press enter since I'm highlighted on 4 right now. And with the TI84, you usually see this menu pop up before any values of slope and y-intercepts are provided for you. And this is just basically a confirmation screen saying that, okay, the values in L1 are going to be used as your x values, the values in L2 are going to be used as your y values, and then this right here, standing for frequency list, we usually leave that blank, as well as the store regression equation row, we usually leave that blank as well. So basically what I'm going to do is scroll all the way down to where it says calculate, and then press enter. And here, the graphing calculator has considered all data points and has found that the slope that we should be using for our linear equation should have a value of roughly 2.07-ish, or 2.067 if we follow the rounding instructions here, and a y-intercept of 292.887-ish. So your calculator is assuming that you are going to write your equation in slope-intercept form, and the value of A represents your slope, and the value of B represents your y-intercept. Now on the next page for this section of notes, it's going to be talking about an R value, and currently there is no R value provided, but there is something that you can do with your graphing calculator to not only get the values of the slope and y-intercept, but also get an R value and at least one other piece of information. So I'm going to go ahead and take you through the process of programming your calculator so that you can see the R value, which is also known as the correlation coefficient. So what you're going to do is press second and then the number 0. And this is the catalog menu, which brings up all the names of all the different functions that are programmed in your graphing calculator. What we're going to do is scroll all the way down to the D area, where we're going to find the function diagnostic on. So there's a diagnostic off, but there's also a diagnostic on. We want to scroll all the way down to where our little arrow is pointing in the direction of diagnostic on. Go ahead and press enter. It's going to bring you back to the home screen and ask you to confirm that you want diagnostic on, and basically we'll just press enter one more time. And should you not change your batteries and not reset your memory on the graphing calculator, diagnostic on will be on from here on out. Of course, if for some reason it goes away, you can just review this video to figure out how to turn it back on. But once this is completed, I'm going to go back to Stat, arrow over to Calc, and go down to option 4. So basically I'm repeating the process of finding the linear regression or line of best fit. And I'll press enter, scroll all the way down to calculate, and press enter again. And now we have some more information in addition to the slope and y-intercept. It's giving us an R squared value, and more importantly, it's giving us an R value. So there's some information as to the significance of the R value, which is called the correlation coefficient. Kind of a spoiler alert here, this value of R is pretty close to 1, meaning that there's a pretty strong correlation between the advertising expenditures and the sales, so that there's a strong linear relationship between the two variables. Okay, so with that, I'm going to go back to this screen here and simply write out the line of best fit, rounding to 3 decimal places. Alright, so the line of best fit, the slope is roughly 2.067. Don't forget the x, plus our y-intercept, which is roughly 292.887. Now, in the context of the variables, remember the dependent variable is the sales, and the independent variable is the advertising expenditures. It turns out that the sales is a function of advertising, so what I'm going to do is just tweak the two variables x and y here. I'm going to replace y with S of A, meaning the sales is a function of advertising, and on the right hand side I'm going to write 2.067A plus 292.887. Alright, but either of these are acceptable answers for a problem such as this. The reason why I chose it to rewrite it in this manner is so that the notation is a little more indicative of what's going on and the relationship between the two variables. Alright, so that's all I have for you for this video. Of course, if you have any questions about it, feel free to let me know. Otherwise, thanks for watching, and I'll catch you in the next one. Bye-bye.